Here's a trigonometry problem, an application problem. Given a scenario, you have to create a graph, and then from that graph, you have to create an equation. And then with that equation, you're going to use it as a model. So a fox population, naturalists find that the population of some animals are periodic, so you know it's going to be a sine or cosine wave. First set of data is at t equals 0, a minimum number of 200 foxes. So I have one value there. When t is 2.9. The next maximum, 800 foxes, happens at 5.1. So I have two data points. So let's see if we can sketch that out. So I know the population of the foxes depends on time. So this is years. And then y is population. So this is time in years. So a minimum number of 200 foxes occurred. So I got a population of 200 at 2.9 years. The next maximum, 800, occurred at 5.1 years. So now that I have those two data points, and I know as well that it's periodic, it's going to be at the low point, at a high point, back at a low point, back at a high point, and continue in both directions forever. So I'm just going to connect these dots, looking like an upside down cosine curve. I know the midpoint right here, 200 to 800, is a total of 600. Half of 600 is 300. So plus 300 plus 300. And then this value right here is a half cycle. So 2.9 to 5.1 is 2.2 years. So that means it's going to do another half cycle in 2.2 years. Right? So if that's 2.2 for a half cycle, this is 2.2 for a half cycle. So 2.9 minus the 2.2 will put me at 0.7. So I have a cosine graph starting up at 0.7, ending 4.4 units later at 5.1. Vertical shift is 500. From 500, I go up 300 and down 300. So now that I have an idea what the graph looks like, I kind of need a roadmap. And that roadmap is going to be y equals c, vertical shift, plus a, sine or cosine. Because we're starting up and ending up, I'm going to call it a cosine. B, I know it's going to be time, and it's not degrees, it's going to be hours, so it has to be in radian measure. T minus my horizontal shift d. So there's my general equation. With that general equation, I could find my specific equation, create a model, then with that model I can make predictions. So C is my vertical shift. So I can see right there, C is 500. A is from that 500, that new horizontal axis, how high it goes up and down. So 500 plus 300 cosine. I'm going to leave that blank for a second. T, because my independent variable x is really in time. T minus d, d is a phase shift, how far it moved over, and it's starting at 0.7. And then right here, b is not my period, but it gives me my period. I know that 2 pi divided by b equals my period. And if it starts here and travels 2.2, 2.2, it travels a total of 4.4 years for a full cycle. I cross multiply to get 4.4b equals 2 pi. Right, that times that equals that times that. Divide both sides by 4.4. That'll give me b by itself. And I have 2 pi over 4.4, or I could reduce that to pi over 2.2. Any questions on that specific equation?
No.
So from my paragraph, I go to points. I connect the dots because I know they're periodic. And then I have a graph. From that graph, I need a roadmap. That's my general equation. From that general, I go to my specific. Now that I have that specific equation, I'm going to go to using that as a model. Okay, and then here are the problems that go along with it. Part A, sketch the graph. We did that. Part B, write an equation. Number of foxes is a function of time t. We did that. Predict the population when t equals 7. So that's an independent variable, 7. Our equation, part C, is saying t is equal to 7. What I do with that is I take that 7 and I plug it in here. I'm going to do that on my calculator. First thing I have to do, because it is not theta, is I have to be in radian mode. In radian mode, I take that 7 and plug it in there. 7 minus 0.7 equals times pi divided by 2.2. So this value right here is 8.99. I take the cosine of that answer, negative 0.9. So this thing's negative 0.9 times 300 plus 500, and I get 227. So when t equals 7, at 7 years, y, or my population, is equal to 227. When x is 7, my corresponding y value is right here at 227. So that makes sense. Okay, and then part D says, when the population is 300, when does it drop below? When does it drop below 300? So you're looking for time, given population. This is a dependent variable, looking for an independent variable. So there's going to be an infinite series of solutions. I'm going to take that 300, sub it in for y here. This is different than what I did before. Before I evaluated that expression, but now I'm solving that equation for t, so I got to work left to right. So 300 is plugged in here. I go 300 minus 500 divided by 300. That's going to give you negative 0.67 equals this whole thing. I'm going to take the inverse cosine of both sides, 2.3. So 2.3 equals pi over this times that. So I'm going to divide both sides by the quantity pi over 2.2. And then I'm going to add 0.7 to both sides. So when y is 300, t is equal to 2.3. See if that even makes any sense. So what I'm saying right here, when y is 300, the corresponding x value is 2.3. It's not my best graph, but I think that's about right. So there's 2.3. I could see that 2.3 is 0.6 units away from here. So this value right here is 0.6 units away as well. So this is 3.5. So when does the population drop below 300 foxes? Between 2.3 years and 3.5 years.